Hello everyone, and welcome to another episode of Data Drip. In this video, we are going to continue from what we had done in the previous video. So we will use the output from the large language model and the segmentation model and feed it to the stable diffusion model to edit the images. And if you want to get a refresher of what we did in the past couple of videos, then do check out the description box for the link to this particular notebook, and there you can find the link to all the previous notebooks. And also do check the video card available in this video on the top either on the left and right side, and that will take you straight to the respective playlist where you can find all the videos for this particular series so that you can go back to the previous videos, get a refresher of what we did there, how we reached this point to this last video in this series, and then you can come back to this particular notebook or video and then continue. So we will get the mask output from the last notebook that we created. So in our notebook 3, we actually created a mask. So in our second notebook, we tried to generate certain amount of captions. One prompt for our segmentation model to generate the mask, and two other prompts that we didn't really use in the last video, which we'll be using today. So one of the prompt would be the caption of that particular image which we want to edit, and the second prompt would be a modified caption that inserts our new subject into the image. So, for example, the previous caption for our image was photo of a butterfly on a hand close up. We want to insert a caterpillar in place of the butterfly. So the modified caption will be photo of a caterpillar on a hand close up. And in today's video, we would try to accomplish two things. First is to feed the generated image caption, generated editing caption, and the generated mask to the stable diffusion model and get the edited image out of that. As usual, we are going to import our packages. First step is to get the image. As usual, we will be using the download URL function from Fast AI library. And as you can see, this is our image, which we are using since the past couple of notebooks or in the past couple of videos. Now, this image is large enough. It is a high definition image, so it is large enough. And I am on a constrained hardware on a small GPU. So I will scale down the image size. Then we have to gather our prompts. If you remember, in the past couple of notebooks, we tried to save our work in files, and we also did save our prompts in JSON files. So these are the prompts which we'll be getting from the uh, required JSON file. And as I explained that these are the two prompts that we are going to use. And this is the mask that we would be using. Now comes our editing step. For this, I would be using the stable diffusion model, a particular version of the stable diffusion model, which is stable diffusion 2.1. In the notebook, I have provided the link to the model card. You can go to the link and see how on which dataset this particular stable diffusion version was trained. The usual way would be to use the stable diffusion edit pipeline class from the transformers library from Hugging Face, which gets us the ability to pass in the model name and downloads it for us. Original diff edit paper on which this entire series is based uses the diff edit framework for editing our image. Hugging Face provides a pipeline for the same. So we will be using that one. And yes, it is integrated in this particular class. For our purpose, we will be using a scheduler to clean the noise in our image and produce a clean image. Now, on a very high level, a scheduler, you can consider a scheduler as a function which cleans noise from the input image in multiple steps and produces a final output, a final image, because that is how a diffusion model works. The scheduler works in certain timestamps, cleans few part of the image, tries to produce the original pixels, then tries to clean some more noise, tries to add some more meaningful pixels and so on. Come to image latents. Now the stable diffusion edit pipeline requires you to provide inverted latents of your input image. Now, if I put it very simply, inverted latents uh, are or can be thought of as numbers which are a close representation of your particular image or the input image. And this particular array or tensors or numbers can be used to reconstruct your image after cleaning the noise step by step. For us, it's becomes easier because the Hugging Face pipeline provides a function known as invert, wherein you feed in your image your mask prompt, that is the caption of your image, and all the different stuffs like guidance scale. For now, we won't go to the guidance scale as of now, uh, but you can think of this number, the guidance scale, as a way to to determine how close the generated image is to your given text or your given prompt. Higher the number, the closer your image would be to your target prompt. Then in the negative prompt, we are going to provide the same mask prompt, and what it does is that it takes in your image and then gives you back the latents of the image or the numerical representation of your image. For the stable diffusion differentiated pipeline, it is required that the mask should be of the same size as the image. So this both the things should be of same size. Now the inverted latent images are of size 96 by 96. So we have to do the or convert the mask into the same size, that is 96 by 96 in our case. I will use the uh, resize function, master resize, because it is a PIL image and the resize function resizes the image. So we'll resize it to 96 by 96. And now both the images, that is the actual input image and the mask image are of the same size. Uh, you might be wondering why the inverted image latents are of this particular size, because this is a smaller size than the input image. The reason being is that uh, since the stable diffusion model tries to be as much efficient as possible, so it takes the input image and reduces it to a much smaller size so that it becomes easier for the model to work on that. The pipeline that we created in the previous section, we would be using that. We will be feeding it the target prompt, the masked image, our latent image, and our mask prompt. So now the inference happens and the model spits out the completed image or the edited image. Let me zoom it a bit. So as you can see in the left hand side of your screen, we can see the actual image, and on the right hand side, it is the edited image. So as you can see, there is a different object now in place of our butterfly. Now the thing is that this one doesn't look like a butterfly. It looks like a bit close to caterpillar, but more of a fuzzy ball kind of thing. Now it might happen that the model that I'm using for editing the image does not actually generalize well enough to caterpillars. Might be the training data or anything. I don't know at this point of time, but I suspect that if I can fine tune it on a bunch of data set of caterpillars, the output image should be better. So this is something for you to try on and do mention in the comments if you get a better result than me. But I would say that given the off-the-shelf models that we have used here in all these notebooks, it is a pretty good result that we have got. So do try it out and let me know in the comment section if you get a better result or if you find some parameters that can be tweaked to make this result or the output image much better. So this is all for this video, and this was the last episode of this video series. Do like, share, and subscribe because more things are coming in. And if you don't subscribe, then it would be very difficult for you to get the updated notifications of any fresh videos that I might upload. And to share it and like it, it makes it easier for others to discover my content as well and gives me a motivation to bring more such contents to you.